All right, the first thing we're going to do in order to do the first page of the assessment readiness test is to create a frequency table. You get to pick in a frequency table the intervals for the number of touchdowns. I would suggest choosing something that is convenient. What I chose to do was do all my single digits, 0 through 9. Then I did my 10 through 19, so there was all my teens. My 20 through 29, that's all my 20s. And 30 through 39, that's all my 30s. The other column is going to be the frequency, which is the rate of occurrence. So I look at my data and I count how many of them were in the interval 0 to 9. So there's 3. Then I go 10 through 19. And I count them, and there were 8. Continuing for the 20s, there are 7, and there are 2 in the 30s. So there's your frequency table. To display the data using a histogram, you're basically taking that data and making a picture of it. So your y-axis is going to be the frequency, which are the counts, and I can see in my frequency table that I need to go up to at least 8. So 1, 2, 3, 4, 5, 6, 7, 8. Make sure you label that. The y-axis should be labeled, the x-axis should be labeled with the number of touchdowns. And here we're going to do our interval. So it's going to start at 0 and go up through 9. So I'm going to make the boundary 10. And I'm going to go up by 10s. 10, 20, 30, up to 40. So in this first bar, there are 3 that are 0 to 9. So this interval here is 0 to 9. If there is a person who has 10 touchdowns, it will go in the next interval, 10 to 19. So then for that one, I go up and put a bar that's 8 units tall. The next one is 7 units tall. And the final one is 2 units tall. That is my histogram. The next thing I need to do for the second part, for B, C, D, and E of that first problem, I need to enter all the data in my calculator. So what I'm going to do is hit Stat, enter on Edit, and put my data into a list. As you can see here, I already have my data entered into List 1. List 2 is not used in this problem. Then I hit Stat again, I arrow over to Calculate, and I choose number 1, and I tell the calculator where the data is that I'd like to calculate the one variable statistics for. So I hit second 1 to bring up the L1, and I hit Enter, and I get a whole bunch of information, and that's going to help me do these problems. So as I look at that, the mean is the top one, the X with the line over it. So that is 19.8 touchdowns. That means the average number of touchdowns in this data is 19.8. The standard deviation is this one. And it says round to the nearest tenth, so that would be 8.4 touchdowns. Now to get the other information, I'm actually going to drag this over so we can remember that. And if I hit down, I'll see all the other information I need. So I can see here that my median is 19 touchdowns. That's the middle number. And my interquartile range is Q3 minus Q1. So that would be 26 minus 13.5, which is 12.5 touchdowns. So now when we do part F, we're describing the distribution. The shape of the distribution is either symmetric right skewed or left skewed. As I look at my histogram, I see that it's fairly balanced left and right. One side isn't stretched out more than the other. If let's say one side is stretched out a lot, for example, like this, so I have a bunch of bars spread out here, and then I got some really tall ones over here, that would be left skewed. It's skewed in the direction that it's stretched towards. I have a tough time deciding which way, so in that case I'm going to say it's about symmetric. Now the outliers. This is actually a problem where it's going to pay off to go to the next part here. And to determine if there's outliers, you have to find the fences. The lower fence is Q1 minus 1.5 times the interquartile range. So if I put in the numbers from what the calculator told me, Q1 was 13.5, and I put 12.5 in place of the interquartile range. Again, these numbers came from this screen here. I can see my Q1 and Q3 and my interquartile range right there. So when I calculate that, it ends up with a lower fence of negative 5.25. Doing the same thing for the upper fence, but for the upper fence I use this formula, Q3 plus 1.5 times the IQR. So in this problem, that's 26 plus 1.5 times 12.5, which gives us an upper fence of 44.75. So that means any numbers that are in that interval from negative 5.25 to 44.75 are not outliers. But anything lower than 5.25, negative 5.25, or higher than 4.75, those are outliers. So I inspect my data. Do I see any numbers lower than negative 5.25? No, because the lowest is 7. The highest is 39. That's not above the upper fence either. So my answer here is that there are no outliers. But remember, you can't just show that, you have to show the fences. So that's what we did here and here. So now going back to the previous problem, I can finish that and say there are no outliers. Now in this case, when there are no outliers, we should use the mean and standard deviation. So I'm answering this question here, explain why you chose the ones you did. The mean and the standard deviation are going to describe the center and spread, because they do a good job when the data is symmetric with no outliers. If the data were skewed or there were outliers, then instead of using center and spread, we would use the median and IQR. So we do that if it's skewed or there are outliers. But as it stands, we're going to use these two. So I just look at those. The mean is 19.8 and the standard deviation is 8.4. So when I describe my center, I will just say it has a mean of 19.8 touchdowns. And when I describe the spread, I will just say that the standard deviation is 8.4 touchdowns. The reason we wouldn't use the mean and standard deviation if it were skewed or there were outliers is because skewedness and outliers unfairly draw the mean towards them, or towards the direction they're skewed, or towards the outlier. and they unfairly inflate the standard deviation. So those wouldn't be as good of measurements. And that's why it makes sense here for this last one, H. What would happen to your answers here if we added the number 84 to the set of data? So that would be an outlier, which means outliers will significantly increase the mean and standard deviation. That's why we don't use them when there's outliers in the data. But the reason we use the median and IQR is because they will be what's called resistant to the pull of the outlier, and they will change less. You could check that by going back to your data and entering in there that outlier and recalculating everything, and we can see the mean went up quite a bit. It's now 22.9. The standard deviation went up a whole lot. That's 15.9. The median's 19, which is exactly the same as it was before, and the IQR is 3. So in this case, it was kind of strange. The IQR actually shrunk. I probably would, no, I'm sorry, I read that wrong. The IQR is the difference in these two. That would be 13, so which is just slightly higher than 12.5. So the IQR is roughly the same as well.